Hey everyone, I wanted to share with you some information about this mathematical property index that you'll find on e-learning and that I've probably talked about in some of my classes or videos. It is a list of properties that I believe are going to be useful to you as you're doing problems this semester. You'll find in this index a list of some definitions and other properties like properties of addition, subtraction, multiplication, division. All the operations are there. We've got some properties for fractions, for exponents. All of our exponent rules are there. All of our logarithm properties, I call them the 10 commandments of logarithms, are there. We also have some polynomial simplification properties like combining like terms, distributive property. Those are going to be two big ones that you're going to use. Equivalence relations, anytime you have something equal to itself, or a symmetric property where two things are equal, you switch them around, switch the two sides of the equation around and they remain equal. And a transitive property, which is your substitution. So if A and C are both equal to B, then you can replace B with C. It's kind of a substitution idea. Okay, so that one may be handy at times. We also have some properties of equality. So the addition property, anytime you're solving an equation, these are going to be very important to you. Adding the same amount to both sides of an equation, multiplying both sides by the same amount, square root property, taking the log of both sides, or raising both sides as a power. All of these things can be useful at different times in this course. And then finally, properties of inequalities as well. You'll see here if you, for instance, with inequalities, if you add the same amount to both sides, the inequality stays the same. If you multiply by a positive, nothing changes. If you multiply by a negative, you have to reverse the inequality. If you interchange the sides, so if A is on the left and then here A is on the right, you also have to interchange the sides. So if A is less than B is greater than A. Those two things are true. And then some stuff dealing with absolute values here as well. So this document is going to be used. You guys are going to need it. And there's a code when you're doing problems. I'm going to call them two-column problems. And you're going to have a couple of them each week, a few of them each week, I should say. I would say on an average, you'll probably have about one problem that you would do as a two-column problem. You probably have one per section that we cover. That's on an average. Now, there are going to be some sections where you have 3 or 4 maybe, and other sections where we don't have any of them. So I would say it averages out to about 1 per section. All right, so I would anticipate if we cover 3 sections in a week, you probably have 3 of these problems to do. And basically what you're going to do is you're just going to do your mathematical work in one column, and next to it, you're going to write the reason for each step. Now, the reason should come from this list, from this document here. This is everything I could think of that you would need, although I have added things to it over time. And so there may be some things that I come up with as the semester goes on that I may add to this or amend it. So if that's the case, I'll let you know and I'll give you a new copy, or I'll upload a new copy. So, but this is an important document, and the code that I want you to use is just what's in the parentheses here, followed by the number under it. So if you needed to use, for instance, the identity property of addition, you needed to add 0 to something, then you would write add 3 next to that line. Okay? Or for instance, if you needed to multiply 2 fractions together, you would put frac 2, and then you would do that multiplication. Okay, So, or if you had to cancel common factors, you could put frac 4 and then cancel. See, the b's here are common and they don't show up on the next step there because they canceled. All right, so that's how you would do that. Some of you may be familiar with two-column proofs. You may have seen in geometry or in trigonometry in the past. And it's very similar to what I want you to do here, where in a two-column proof, you would do a step of the proof or a line of reasoning and give the reason next to that in another column. It doesn't have to be like a formal column, like a table setup. You just need to make sure that you have the reasoning immediately next to the step in which you use it. Okay, and that should be true. Then I'm going to be grading more based upon the code. Like, you know, if you write poly 2, that's for the distributive property. I'll be grading those more based upon the code in the reasoning column than I would based upon the work itself. Okay. The problems that you do, they're going to be from the textbook. You of course have access to the ebook in my math lab. And so the problems are typically going to be taken out of the textbook, and then you can submit those, handwrite them on paper and submit them. You may also, or you will also, have some two-column problems on your tests as well, so be prepared for that. I will show you examples of myself doing two-column problems so you get a feel for how that works. I will show you those either in class or in my videos, depending upon the format of the course. Okay, so I hope that helps to explain some things with this mathematical property index. It will be available for you in e-learning under the content tab, probably in the Student Start Here module. Okay, thank you.